Okay, Algebra 2s. Told you I'd come back with some more information with Pascal's triangle and combinations. Okay, so here I've written out the Pascal's triangle in combination form. Notice all the C's. We talked about that last video. So 0, take combinations of 0 things, that equals 1. 1 combination of 0 things, that equals 1. So this becomes 1, 2, 1, and 1, 3, 3, 1, and so forth. So we're going to use this idea of combinations and these coefficients upon coefficients, to do what? To to expand binomials. Okay, binomial expansion using this thing called the binomial theorem. Okay, for the theorem part, let's look at this, and then we'll go through what this means. So we have a binomial, that's two-term thing raised to some power. And then you see this combination thing here, NCR, n things taken r at a time. And that's your A, that's this number here, whatever it happens to be, your first term. It's going to n minus r, so whatever you started at, okay, each term is going to increase, and then the B is going to go up. So let's take a simple example. Let's take x plus 3 squared. Okay, something nice and simple. Okay. So what this means is n is 3, so he's saying 3, and the first choice, r is 0. 3, 0, and that's our x, times 3 to the 0 power. And this is not just plain on x, but it's x instead of second. Why did I put a 3? It must be going to the third power. And it's 2. 2 COX squared 3 to the 9, plus the second one would be 2 combination taking 1, because r is now 1, x to the 2 minus 1, the first, and 3 to the r, times 3. And finally, 2c2, with do c do, 2c2, x to the 0, and 3 to the second power. But wait a minute, these things aren't numbers. What are they? What are these things? Oh, they're combinations. They're from our Pascal's triangle. But we don't want them in terms of combination, and we don't want to keep calculating these combinations. That's why we did number 19, and we expanded our Pascal's triangle down to the 10th line. So if this one was to the second power, so this is to the 0th power, this is to the first power, and this is to the second power. So these are numbers that will be multiplying our coefficients. So we had this, that's our 1 x squared times 1, plus 2c1, that's 2, x times 3, plus 2c2, well, that's another 1 again, 1, x to the 0, that's also 1, and 9. So we can see this really expands out to x squared plus 6x plus 9. If you remember when we did this before, we said x plus 3 times x plus 3, and we got your x squared, 3x, another 3x, your x squared, your 3x, another 3x, and the 3 times 3, x squared plus 6x plus 9. So using this binomial expansion, we can expand these binomials and get the correct solution, the correct expression. So let's do it on a more difficult one where n is not equal to 2. Let's take that same, we'll take the same thing. I'll do x plus 5 quantity to the 4th power. So now we see that n is 4, and r is going to be decreasing from 0, started at 0, r is increasing actually from 0 to 4. So we could write it out the long way. N is 4, 4c0 x to the 4th power times 5 to the 0th power plus 4 combination 1 x to the 3rd power 5 to the 1st plus 4 combination 2 x to the squared times 5 to the squared. Notice how these exponents are always adding up to your n, always. Okay. And let's continue this on out the long slow way. That's 4c3 x times 5 to the 3rd, and finally 4c4 x to the 0, 5 to the 4th. But when you go ahead and do these, don't bother to write it out this way unless you just feel like doing all that writing. Find out what these numbers are. Okay, we all know that 4 taken 0 is going to be 1. And anyway, let's look at our Pascal's triangle again. So we're to the 4th power, so we'll slide over and look at our Pascal's triangle. 0th, 1st, 2nd, 3rd, 4th. And the second number is always going to give you a big hint as to where you are. Okay? So those are the numbers that we're going to be plugging in, okay, for these combinations. So you got 1, x to the 4th times 1, 5 to 0 is 1, plus 4, our number is 4, x cubed times 5, plus, what's the next one? 1, 4, 6. 6, that's what that is. X squared times 25. And plus 4, 3. So just do 6, and now there's 3. That's 0, 1, 2, 3. And then that would be the 4. So we got 4. That's what the 4c3 is. X 5 to the 3rd. It's all multiplying. And then another last one, 4c4, which you know is 1. X to 0 is also 1. And then 5 to the 4th power, 625. So we'd write out that whole expansion as x to the 5th plus 4 times 5 is 20. Our coefficient on the x to the 3rd term is now 20, plus 25 times 6, that's 150, x squared, plus 125 times 4, that's 600, x plus 1 times 1 times 625, 625. So there we have the expansion of this binomial, x plus 5 to the 4th power. It's all a matter of remembering those things, using your Pascal's triangle, remembering where you are. And these numbers are going to tell you where you are. That'll be 2nd power, 3rd power, 4th power, 5th power, 6th power, 7th power, 8th power, 9th power, 10th power, 11th, 12th. Oh, sorry, ran out of triangle there. Now this book is also going to ask you to do something kind of crazy. It's going to say, okay, I'm going to give you x plus 7 to the 5th power. I'll go, to the 8th power. And then I'm going to ask you, what is the coefficient on the, I don't know, give me a number 5, on the x to the 5th term. So you say, ooh, how would I figure that out? Do I have to expand this thing all the way out and get it? No, we just remember our general rule, which is still here. NCR, A, N minus R, BR. So here n is 8, so you got 8, C. Now what is R? Well, we get into the 5th power, so to get there we got to go n minus R. 8 minus 5. 8 minus 5 equals 3. So we're taking 8C3, and we're taking our x, and it's to the 5th power, times, that's 7 to what power? Well, we need to get 8, so 7 to the 3rd power. And then we have to figure out what this number is. That's where you go back to your Pascal's triangle, or you could plug it into that formula. You can plug it into that formula and work it out. You can punch it in your calculator and work it out, or you can go to Pascal's triangle. This is to the 8th power, 7th power, 6th power, 5th power. So that's our 8C3. This is 8C0, 8C1, 8C2, 8C3. 8C3, squeeze, yes. 1, 2, 3, no, oh, sorry. So what we said that was 56. So our coefficient will be 56 times 7 to the 3rd power, x to the 5th. Once you figure out what that number is, and that's just a matter of punching it into your calculator. See, that's 343 times 56. I don't really feel like doing that in my head. 6 times 3 is 18. 6 times 4 is 24, 25. 6 times 3 is 18, plus that 2 is 20. 5 times 3 is 15. Carry the 1. 5 times 4 is 21. 5 times 3 is 15, and add 2, 17. And you can see, because you probably already calculated it in your calculator. Oops, that's 2. 19,708. Is that what you got? So our coefficient would be 19,708 on our x to the 5th term in this expansion of x plus 7 to the 8th power. That's the other thing they're going to have you do. Again, I just went back to the original formula. Sorry about that. Okay, back to the original formula. Use my n, which was my exponent, and r, which is subtraction from r to get down to that decimal, that exponent place, 5th place in this instance. Okay. And then we just cranked it out using our Pascal's triangle, found our number, realized what we had to raise that other number to. The other number 2 has it as an exponent. Those have to multiply together, and then we have our coefficient on that particular term. Okay. So those are the fun parts of this exercise. Your other fun part is to remember how or when to add or subtract your combinations. So if you look at numbers 48 and 49, this is on page 696. Okay. You have a question about music, okay? And they're going to select some music. In this case, they're selecting CDs. I don't know when was the last time you bought a CD? 1, 2, 3, 4. So there's 5 categories in the contemporary, 1, 2, 3 categories in the classical. You're going to get 2 contemporary and 1 classical CD. But you're just going to kind of pick one. You want to know how many combinations there possibly are. So you can pick out of these various topics. So you see you got 5, choose 2. And 3, choose 1. Now you notice I use the word and. Okay. If you're going to use and when you use these combinations, that means you're going to be multiplying these combinations. So you can plug that into your calculator and use your Pascal's triangle. This is 5C1, 5C2. Okay. So that's 5. This is 5C0, 5C1, 5C2. And 3C1 is 3. So that takes us to a total of 30 possible combinations. 5C2 was 10, 3C1 was 3, and it's an and, so they multiply. If you look at number 49, is that the one? No, I'm sorry, number 50, sorry. Number 50, okay, if you try that one. The arcade games. Okay. So you're going to play at least greater than or equal to 14 arcade games, and there are 20 from which to play. So we have to then say we're going to play at least 14. So we're going to play 14 or 15 or 16 or 17 and so on. Notice how I use the word or. Okay. So we set it up again, same combination idea. We got 20 and 14. So we got to do all these little combination things. 20C14 plus, this is an OR, 20C15 plus 20C16 plus 20C17 plus 20C18 plus 20C19 plus 20C20. And you work out what all these things are. Can't use my Pascal's triangle because I didn't go down to the 20th line. Bummer. So I have to calculate all these things out. I know that's 1. Okay, and this is 20. And we just calculate all those other ones out. I'm not going to do it now because we're running long on this video, but you can do it. Just remember your formula. That'll be 20 factorial, 20 minus, we're at 18, so it's 2 factorial and 18 factorial. And then start canceling out your top and bottom, and you can do that. Or you find the button on your calculator. Hunt and search on your fancy TI-84 calculators, and you could find the button that's going to be your combination button. I think it's in statistics. I can't remember exactly, but I'll let you know. And you'd add that all up, and that will tell you how many different combinations of ways you could play at least 14 arcade games if there are 20 to choose from. Okay, so go ahead, give these exercises a try. Have fun with it, because it's going to lead us into probability, which is where we're heading. Take care, folks. And remember, don't forget about Pascal.